Hi, my name is David Lindlbauer, and I'm an assistant professor at CMU's Human-Computer Interaction Institute. My research is motivated by one main observation. If we look at the digital world, it is fully controllable. We can effortlessly perform changes such as in color, texture, or even shape. This is what the digital world is meant to do. Having the same level of control in the physical world, however, is nearly impossible. So my research is motivated by three main questions. How can we bring more virtual into the physical world? What can we do if we had a fully controllable physical world? And how can we balance the virtual and physical world? In order to answer the first question, how can we bring more virtual into the physical world, I create new types of enabling technologies. For example, I created devices from smart materials that change their shape purely optically, and thus allowing the users and system to communicate. I also augmented devices through external devices such as projection mapping. And also I created new types of augmentations by modifying the environment around a target object, like here the glass. However, if we look at those enabling technologies and other tech such as virtual reality, we notice that there's a gap in between those two. And I'm interested in, if we close this gap, how does this influence human perception? And what kind of applications would this enable? Here's one example of an approach that I created that closes this gap. It's called remixed reality. The user is wearing a virtual reality headset, and what they're seeing is not the pure environment, but actually a live 3D reconstruction of the room. What this means is that they can move in the room freely, but still we can fully control the geometry in the room, enable applications like here, I'm cloning a person in VR, obviously. But this has very interesting applications, for example, in telepresence, maintenance, or education. The last question I'm very interested in is, what would happen if we had a technology that can display anything anywhere? And I believe mixed reality is a contender here. However, I would argue that mixed reality is inherently context sensitive. The environment changes constantly once the digital world is no longer bound to the flat displays of our computer screens or phones, and therefore any kind of user interfaces has to adapt in a context sensitive manner as well. So I'm interested in, how is mixed reality perceived by users, and in terms of visual perception skills and cognition, what are the influencing factors, and how can we model those factors? And if we know that, we can build computational tools to build smarter, more context-sensitive user interfaces and approaches for mixed reality. So one example I created here is where we use combinatorial optimization to change when, where, and how to display virtual elements in an AR setup based on users' current context, meaning their task and their cognitive load. And also we started into looking at visual salience and visual attention to make these smarter interfaces for mixed reality that enable a more beneficial user experience. Besides this three-step approach where I use perception to understand more about mixed reality and build computational tools, I believe that a very interesting area of research is also to use mixed reality to gain insights into human perception skills and cognition. This enables a very diverse set of application areas, for example, in health, where we started using virtual reality to investigate balance disorders. So in summary, I'm working at the intersection of perception, computational tools, and mixed reality. For example, in application areas such as productivity, ubiquitous information, in situ and remote collaboration, telepresence, and health, and making sure that we're not stuck in front of our 2D screens for another 30 years. Thank you.